DC fast charging explained in electric vehicles. Future of EV. What is DC fast charging? Why is it called level 3 charging? What are the advantages of Dcfc? What range can a DC fast charging device add to your vehicle in less than 5 minutes? And what is the future of an electric vehicle? So, welcome to Techverse, you all. We are back with another interesting video. Today, we are going to talk about DC fast charging in electric vehicles and the future of electric vehicles. So, without any further ado, let's get into the video right away. Electric vehicle charging speed is a significant consideration for automobile buyers as they balance the advantages and disadvantages of the vehicles. An electric vehicle owner's daily routine can be severely disrupted by the time it takes to charge their vehicle. Electric vehicles can currently be charged at a maximum charge rate of level 3, which is also known as DC fast charging or Dcfc. A Dcfc device can increase a vehicle's range up to 100 kilometers in less than 5 minutes. When traveling long distances, Dcfc is the best option because it is the fastest out of the 3 levels. Dcfc could be the key for EV users to take longer road trips and travel further along America's highways in a more practical and time-efficient manner as EV ranges increase and EV infrastructure becomes more widespread. Fast-charging DC stations on highways make it possible for EV drivers to refuel quickly, conveniently, and affordably. Federal and state government cooperation has led to the development of infrastructure along with the interstate highway system and other major freeways known as alternative fuel corridors. So what makes level 3 DC fast charging so fast? The 3 EV charging levels represent the rate at which a charger replenishes the battery capacity of an EV. Kilowatts are the units used to measure charging power, and a single kilowatt provides around 3 miles of driving range per hour. The faster an electric vehicle's battery can be charged, the higher the charger's output should be. Charging at 1.3 kilowatts to 2.4 kilowatts at a regular 120-volt household outlet is considered level 1 charging. This is the equivalent of a 4 to 6 mile per hour electric vehicle range. An overnight charge can extend a vehicle's range by 50 to 60 miles. For an EV with a range of 250 miles and an empty battery, a complete charge can take up to 2 days. Level 2 charging requires a 240-volt outlet and generates power between 4 kilowatts and 18 kilowatts. This equates to a range between 12 and 54 miles per hour. An electric vehicle with a range of 250 miles can be fully recharged in less than 5 hours if the charging rate is maximized. It could take as long as 21 hours at the lowest rate. Public spaces like malls and parking garages are among the locations where level 2 charging stations are found. Charging an EV at level 1 or level 2 requires alternating current, or AC, which must be converted to direct current, or DC, by the onboard rectifier before reaching the battery, because EV batteries can only accept DC current. At level 1 and level 2, the time it takes to charge is due to the conversion from AC to DC. Level 3 charging, or DC fast charging, provides a significantly faster and more efficient charging experience. Dcfc chargers can be found in public places, car dealerships, and fleet management businesses. They can range from 50 kilowatts to 350 kilowatts in output. Depending on the vehicle's voltage capacity, they can recharge an EV battery to 80% in 15 to 45 minutes. Due to Dcfc's higher voltage and direct current flow into the battery, EV owners can save hours of charging each day. Now let's see how the DC fast charging works. Fast charging for electric vehicles is divided into 3 main categories: the CCS, CHAdeMO, which stands for Charge de Move, and Tesla Supercharger. The charging port connector on each of these devices is exclusive to that specific model. CHAdeMO remains the industry standard for some automakers, but CCS is the most widely used. However, the CCS or CHAdeMO connectors on most DC charging stations can be used to charge the device from the same unit. However, Tesla vehicles can also be charged at CCS and or CHAdeMO fast charging stations with an adapter. EV batteries have a maximum amount of power that they can accept during charging. In kilowatts, this acceptance rate or maximum power rating is expressed. It varies greatly from one vehicle to the next. Many EVs now on the market have an acceptance rate of 50 kilowatts. However, other newer EV models can take charging up to 270 kilowatts. DC Chargers have been improving their outputs to keep pace with battery size growth since electric vehicles first hit the market, and some can currently deliver 350 kilowatts. When it comes to electric vehicles and electric vehicle chargers, there may be some confusion about their compatibility. Due to this, it doesn't matter what kind of power your car has, as long as the charging station has enough kilowatts. In other words, an EV that charges at 150 kilowatts may use a 200 kilowatt charger just well. The charger and automobile will communicate, and the charger will only provide what the car is capable of receiving. It would charge at 150 kilowatts in this situation. The battery management system of the car is in charge of keeping track of the charging process and allowing as much energy as the vehicle is capable of accepting. That also applies to the polar opposite case. When a vehicle's charging capacity is limited to 150 kilowatts, a 200 kilowatt charger can still be used, but the car will charge at a slower rate. It will charge at 150 kilowatts in this instance too. In order to prevent the battery from being overcharged, the Dcfc rate drops dramatically when the battery is charged to more than 80%. Because of this barrier, many EV manufacturers will often say that it takes a certain amount of time to fast charge the battery to 80% capacity. But the Dcfc has its own downsides. There are some drawbacks and limits to Dcfc, despite the evident advantages. There are only a few Dcfc charging stations available. Fewer Level 3 chargers exist than Level 2 charges. The Dcfc device takes less time than a Level 2 charger, but it's not always easy to find or close enough to go to. Second, the expense of 480-volt electrical service, which Dcfc requires to operate, makes it an expensive system to install and use. Dcfc equipment is more expensive than Level 2 infrastructure because of the greater voltage it requires. In addition, EV owners must pay a higher cost per minute to charge their battery when using Dcfc because it is the fastest charging option. The pricing difference between Level 2 and Level 3 might be anywhere from 25% to 40%. Third, regular use of Dcfc may cause the EV battery to overheat, which can damage it. Dcfc charging is expected to exacerbate battery degradation over time by repeatedly heating the battery. Some automakers have urged that EV owners refrain from utilizing Dcfc on a daily basis in order to reduce the risk of overheating. Dcfc's negative impact on battery life, on the other hand, is mostly unproven, and the subject is still up for discussion. Within the next 5 years, it is anticipated that the market for fast DC chargers would expand at a compound annual growth rate of around 30%. The demand for Dcfc is rising in parallel with the popularity of electric vehicles in the United States. Because of the ease of Dcfc, even people without access to a home charger, such as those who live in apartments or condominiums, might think about purchasing an electric vehicle. Dcfc, despite the expansion of major networks like EVgo, ChargePoint, and Electrify America, is still in short supply. Due to the high installation costs and power requirements, Dcfc stations are unlikely to be installed in private residences. A typical Dcfc station costs anywhere between $50,000 and $100,000. Tesla superchargers account for more than half the country's 17,000 Dcfc units. It is estimated that in the next 5 years, California alone will need 25,000 EVs to meet its goal of 5 million EVs on the road by 2030. As Dcfc spreads across the country, it may be difficult to keep up with demand in the near future. So, this was all about this video. I hope you liked the information given in the video, and if you have anything on your mind, feel free to comment below. Also, don't forget to like, share, and subscribe to get more videos like this. Also, hit the bell icon to get the notification of the latest updates on the channel, and thanks for watching!